In this video, we're going to learn how to solve a square root equation. Now, the key to solving square root equations is to isolate the square roots and then square both sides of your equation. So for the first example, we're going to subtract 3 from each side first. So the square root of 2x minus 3 is isolated on one side of the equation. So we have square root of 2x minus 3 is equal to 5. And then we will square each side of the equation, which will give me 2x minus 3 on the left, and then 5 squared, which is 25 on the right. I'll add 3 to solve, and then solve for x, and I'll get x is equal to 14. Now, you do get rid of a square root and change your problem from a radical equation to a polynomial equation. So there's a potential that you could get an extraneous solution, meaning one that doesn't actually work. The best way to make sure that this does work is just to plug it in and see if it is a correct statement when you replace x with 14. So my check, it would be 3 plus the square root of 2 times 14 minus 3. So we'll have 3 plus the square root of 28 minus 3, which will be 3 plus the square root of 25, which will be 3 plus 5, which is most definitely 8. So it does work as a solution. So my answer is x is equal to 14. So let's do this with another example. So here I want to isolate that radical, so I'm going to add 5 to each side of my equation, giving me the square root of 4x plus 1 is equal to 5. Then we'll square each side of the equation to get rid of the radical. In doing so, I'll have 4x plus 1 equals 25. Subtract 1, then divide by 4, and you'll get x is equal to 6. And just to make sure that it is correct, if I were to plug in 6, I would get the square root of 4 times 6 plus 1 minus 5, which will be 24 plus 1 minus 5, which is the square root of 25 minus 5, which should be 5 minus 5, which is 0. So it definitely works. That is a solution. Now, what do we do when we see an x outside of the radical? Well, you still handle it the exact same way. You'll isolate your radical, so I'm going to add 5 to each side. Give me the square root of x plus 7 is equal to x plus 5. And then I'll square each side of my equation. So I'll have x plus 5 squared on the right, which is a binomial squared. So this will leave me with x plus 7 is equal to x squared plus 10x plus 25 when I multiply x plus 5 times x plus 5. Now, this finished solving this is now a quadratic equation, so I'll have to move everything to one side and factor. So I'll have x squared plus 9x plus 18. I'll factor that, and it'll give me x plus 3 times x plus 6. And my two solutions will be x equals negative 3 and x equals negative 6. And I want to make sure it is a correct answer, so I'm going to check both of these. First, I'll check negative 3. When I plug negative 3 in for x, I get negative 3 plus 7 minus 5 should equal negative 3. That is the square root of 4 minus 5, so it's 2 minus 5, which definitely equals negative 3. So x equals negative 3 is a solution. Then I'll have the square root of negative 6 plus 7 minus 5 should equal negative 6. I'm going to replace those x's. That gives me the square root of 1 minus 5. But 1 minus 5 does not equal negative 6. That is not true. So this is not a solution. So I only have one solution. This ended up being extraneous, meaning it didn't work. So down here I have the square root of 11x plus 3 minus 2x. I'm going to add the 2x to the right first. And then I'll square each side of my equation. That gives me 11x plus 3 is equal to 4x squared. This is now a quadratic equation, so let's move everything to one side. So I'll have 4x squared minus 11x minus 3. And I want to factor this, so I'm going to look for two numbers that multiply to 4 times 3, which is a times c. Which is negative 12. And then add to the middle number, negative 11. This is that b term. The two numbers that do this are negative 12 and 1. So I'm going to factor this by grouping. So I have 4x squared minus 12x plus x minus 3. I just split that middle of negative 11x into two terms. And then I'll group them 2 and 2. First group has a 4x in common, and I'm left with x minus 3. Second group doesn't have anything in common, so just plus x minus 3. You can see that common factor there of x minus 3. And then 4x plus 1, an understood 1 when you factor that out. So setting both of those factors equal to 0, I get the two solutions of 3 and negative 1/4. Now I'm going to check both of these solutions to make sure they work. First I'll check 3, so I'll have the square root of 11 times 3 plus 3 minus 2 times 3, and this should equal 0. So I'll have the square root of 33 plus 3, which is 36, minus 6, which is 6 minus 6, so that definitely works. X equals 3 is a solution. Now let's try negative 1/4 as a solution. I'll have the square root of 11 times negative 1/4 plus 3 minus 2 times negative 1/4. And I can already tell this will not be 0 because when I do negative 11/4 plus 3, that will give me 1/4, but over here I'll have plus 1/2, which is a problem because I know this should be positive plus a positive. There's no way that can actually equal 0. So even if I finish going on and got square root of 1/4 plus 1/2, that would actually equal 1/2 plus a half, which is 1 and not 0. So negative 1/4 does not work as a solution. So I only get x equals 3 as a solution. Now the last problem I want to talk about is a unique one called a repeated logic problem, where you have the square root of 2 plus inside of that the square root of 2 plus the square root of 2 plus the square root of 2, and it goes on forever. Now how do you handle a repeated logic problem like this? How do you find its exact value? Well, the best approach is actually to take that expression and just set it equal to some variable. And the reason why is this entire logic is inside of the square root. Meaning if I covered this up, you'd be like, oh, that was the x I just set. That's just what I set x equal to. So I can replace all of this on the inside of the radical with the x on the outside, since that's what it's equal to. So I end up with x equals the square roots of 2 plus x. And then to solve that equation, it's now a square root equation, so I can just square both sides of the equation, giving me x squared equals 2 plus x. Shift everything to one side, giving me x squared minus x minus 2. Factoring, you get x minus 2 times x plus 1. So the two possible values for this expression would be 2 or negative 1. Now obviously this needs to be positive because there's no subtraction going on, nor does it start with any negatives. So that cannot be a solution. Only 2. So the solution to this is that this expression is just equal to the number 2. And that is how you solve a square root equation.